Do, do, do. So there you go. Let's just continue where we left off. We added a CON interface. We got the LIN bus, and we got the CON bus as well. And we're using hierarchical blocks. Can I copy these? And then just go here and paste them? Sure can. Maybe here there are more inputs. Not this one. So this one is an input, this one is an output. This is an output, output, output. Yeah. So this one is an input here. The rest is TX output. Ah, never mind. This one is an output here. And all of these are inputs. Input. I'm trying to use hotkeys as much as I can. So it's very easy. Love it in KiCad how you click an object and press E, and you get up to properties, and you can change pretty much everything here, I think. Okay. So we can sync up these at least. And we'll line them up like this. And we can use a bit more of the space here. Come on now. And again, we do it because so that we can modularize our design. And this I will probably split into each block. So instead of one network page, I'll have a LIN page, CON page maybe. You can argue that you're making your design more complicated than it has to be, but I kind of enjoy it. I kind of feel like, why shouldn't you? It just looks nice. It looks like you put some thought into it, at least. And if another person would open up your design and see this, then they will be like, oh, this person thought about it, at least. Can I make spacing in between? It'd be nice if I could have a little bit more space between the letters. Automotive ECU. Master. Controller. This stream is ever changing. My work is ever changing. I'm constantly coming up with better ideas, or just evolving, I guess, like we all should in every aspect of life. Display. This we might scrap. Not even sure if we'll have a display here. We'll have some type of interface. But if it's going to be display, I haven't decided yet. We loosely defined our master commander. I'm using a lot of different words now. This was when I only considered a LIN network, so then I was using the commander, master or commander name for this one, and then the slaves would be responders, rather. Yeah, last time we added a CON interface. And that is ready. We'll leave this not connected for now until we figure out the supply. But the idea is just that we have a way to, I guess, when we're woken up, we can enable the power supply, the regulator, and then communicate on the bus. We get this wake-in signal either locally, and that could be over another interface. So we trigger this, and this inhibit pin goes high or whatever, and initiates. I see I wrote the same thing for the LIN transceiver. So if we should connect it to U2 enable, U2 would be this one. Because I guess these transceivers, they have power from, in this case, the battery, and it enters some low power mode. Same here on the battery line. It's consuming very little, and then here is for the bus itself. Yeah. But instead of speculating, we will dive deep into this interface, the LIN interface as well. Oh, what should we do now? I really wanted to add a Ethernet interface also as a main in, the main in for, let's say, the rest of the vehicle. Okay, wait. So we got this one. That's 32K 116. And we're purposely starting that small. We could have just as well chosen this is not that different, just some more IOs. Here we get FlexCAN. Here we get Ethernet on 148. Other than that, we have UART, SPI, FlexIO, IIC, whatever that is. We would have to go all the way up here to get Ethernet. Up to 1. Okay, but this is up to 1. I have to go up to this one. 144. Huh? Oh no, not implemented. $148. What do we want this thing to do? It's got a LIN interface. icon interface. This is what I'll do. This is what I will do. Like this. I'm basically looking for some common what is ECU form in the car? Okay. I think what we need to do is define I think we have to define a little bit what some of the slaves needs to do. So, for example, now this is what we have. I would need to get some connectors. And we have a network, power management. We need to route these up, of course. And then this we take away. Yeah. You know what we will do? First, we'll make it a little bit simple for ourselves. We got the Limbus. Could we have the Limbus on the board? And we put some connectors here, some connectors there, or we can just do it on traces too. But just like just start with, for example, some headers. Headers to here, and then a lane transceiver. Browser lane trans. Right. Oh, this is just multiple. Back to the drawing board. I'm really trying to come up with a nice way to, yeah, for this ECU to, I mean, perform any tasks, right? So far, we only have a microcontroller and some interfaces. So the Limbus, for example, could go to a bunch of different slaves doing something, providing some data to the microcontroller or to the master. Then the master can also provide some information. Over the LIN bus or the CON bus. Just trying to think the best way to do that. For example, it could be interesting to have a PCB where you have you have kind of like the main board. That was not very nice. In the middle, main, and then you have like, you have some headers for LIN, and then for CON, and then you can have, so if this is the whole board, you can have slots ready for module that we can build. We can build modules. And then cables over. So in this case, it would be 3 power, ground, and Lin, for example, if we are the ones powering. Which we should, I guess. Same here. And then we can, you know, measure, put some test points on all of these PCBs. It won't be this big, probably. Be a miniature. I like small ones. Or that we just have like a main connector out. We have one to PC. Here we just plug into ECUs that we make. Also connectors. Like this is ideally what I want to do. Oops. Yeah, now we got a little bit. What should I do? We haven't really decided what the master should do either. Lin will be the main communication interface between the nodes. Kano will be the main interface to other more heavy-duty ECUs. Undecided. What they should do. Just that they're heavy-duty. Sorry. Damn, I'm stuck. A little bit stuck now. Let's see if we can define a little bit what the slaves will be doing. And I will do like this climate module. Because that's a known ECU. And just Google it real quick. Common ECUs in a vehicle. And you have, of course, stuff like brake module, acceleration, engine control module, and stuff like that. Which could be very interesting to look into how you would implement that. But I think climate can be interesting as well, since it will have some interfaces for the user. Climate module. Hold on, let me Google some images. Climate module ECU. Kind of like this, right? Babco Customer Center, Galaxy Jaguar. What is this? Repair. Wow, check this out. Some Max Froster fan. Buttons. Here, loads of buttons like circulation, temperature fan, defrost. And that's what I'm thinking. In order to work with this, to actually create automotive electronics, we have to have, let's say we have to have a master computer or this MCU controlling everything, getting notified of, for instance, when the user presses the auto button, it should put on some, what does the auto button do? It puts on maximum fans, right, in order to get this temperature. Here's max heat on. And in order for this module to know how warm it is in the cabin, they need to have a temperature sensor, right? They need to be notified how warm it is then afterwards. Maybe it's one sitting in here, I don't know. Or maybe just, this is just vents or something. Heater controller. Did I change back? Yes. Hey, by the way, nice to see I have a viewer. How are you doing? Thank you for watching. Like, let's take the climate control. Climate module. I'll just put that over here and then we'll figure out how it would work together with the commander. So we don't know yet if all of this functionality should be on one PCB or if we should separate it, connect this over via LIN. The climate module has a temperature, or it's not a module. Climate information provider. Climate information provider. Which could be just a simple microcontroller. And a temperature sensor. Right? Doesn't need any debug or nothing. Power management maybe it should have. Make it tiny because it's going to be a tiny ECU. I think this makes sense that we start defining what the slave will do. This in turn will tell us a little bit about this master. What type of master is it? When we think about it, the master could actually be a climate module where it has all types of human-machine interfaces, buttons and such. Or it can be hidden and it does something in the background. But like it could be a module like this, and the slaves to this component would provide information about the temperature, or for example, give inputs to the fans. For example, this fan. When it's off, it's off. There's no RPMs on the fan. You pull it up to max, it will be maximum RPM specified for that fan. Maybe there's a fan sitting on next to the driver, in front to the left of the driver. I actually don't know how climate system in cars. It's crazy how important a climate module is in today's vehicles. Climate control, MCU, current drivers, air conditioning unit, flap control, actuators, humidity sensor, multi-cabin temperature sensor, external temperature sensor. This is basically what we're talking about. And they got an LCD screen, right? User temperature and humidity settings. So inputs from the buttons, the switches maybe. So that could be something that our ECU will do. Then we can have a humidity sensor, temperature sensor, humidity / temperature sensor, sending over information on the LIN bus. Wireless charging. It's interesting because it's actually quite complicated. Okay, display is back. Display is back. Now I need to make. How do I? Display. Already exists. Ah. Where did that go? There you go. So display. So yeah, the system design is not good enough right now. Lin SOC. Like, let's go here actually. And if we're just thinking about a slave. Lin transceiver. For example, this one. Nah. Lin SBC. Lin SOC. I'm really stuck right now, actually. Doesn't help that I'm streaming. What should the master do? It should receive a lot of data. It should receive data on Limbus and also control different nodes. If you have an idea what this automotive ECU master controller should do, please let me know. If you have any good ideas, if it should be, you know, a climate module or ECUs and cars. I guess we're kind of making a body controller. Let's see, I can copy this image. So, inspiration corner. Like that. Inspiration corner. So this is various automotive electronic control units, ECUs. From the top left, engine ECU, head unit. So the display, I guess, in the beginning. Instrument cluster. Right. So behind the wheel. Driver seat control. Body ECU. So that could be controller for controlling the doors, or windows, windows, lights in the car, keyless entry ECU, data link, rear view camera, side obstacle detection ECU, telematics box, parking aid module, driver door control, TPMS ECU, restraint control ECU. Parking aid module. So ultra wideband antennas, for example, on the tailgate or behind, I guess, wherever they would be placed. So they start beeping. You also have a rear view camera. That maybe helps you out. Driver's seat control. Yeah. Okay. So we'll also include here user interface. So it will have, you have a display. It would also have a buttons. For example, user presses the all on button to turn on all lights in the cabin. So that could be a thing that the master does. It has a button. You press it, it turns all the lights on. And the lights, which is not on the master, light is here. LED. Right. So we'd also have, of course, LIN interface. So that could be a thing, right? So when a user presses the all on button, it sends a signal first to the MCU, then through the LIN bus to the light ECU. Yeah. What will the slave nodes do? I basically written it up before. So they have LEDs, RGBs on one, and then for example this climate module or climate ECU could have temperature, ambient light. So on the master side it would mean button. One button for this purpose. That's not a lot of load on this LIN bus, but we will be able to, we'll come up with something more. Driver door control. All of those buttons too. Keyless entry. Yeah, no. Really a little bit stuck today, guys. A little bit stuck. Let's say, for now at least, we take away this future connector and we actually put a connector there. Or at least something. Terminal. Like 2 screw terminals for power and ground, for instance. So this would be this. This we can hide. J1. See here. Connector. And let's say, for example, Q, of course. So. So. Limbus. So in this case, we could have more. Actually, we could like do like this, right? Let's say. Can you do it like that? Let's wait. And I do the same here. Just do 8 maybe. Oops. J2, J3. So just for future connections to Limbus, so if we would have one slave here, another one here, and another here, etc., we can connect them also to the Limbus. Same with the Khan. So here we can have an additional 3. The same here, additional 3. And then we just connect them like this. Yeah, we can do that. Lin is scheduling. Khan is collision avoidance. So prioritization and stuff. So you can just connect them up like that. You have termination on the slaves then. As well as here, I guess. So, and this is why this is so good, because I can put into its own block, right? It will speed up my design time tremendously. So here I have everything in one block. I could split it up and have a Khan block. So if I need another Khan interface on one of the slaves, I'll just copy that block and use it the other way then. But for now, I keep them together. Oops. On high. On low. So screw terminals and just pins. Let's see what other type of connectors they have. USB. RJ. Barrel jack. D-sub connectors. Test points. Connector audio. Audio jack. Generic connector. Yeah, here we have some fans as well. That we can use for something. Especially if we're making a climate module. Okay, at least we got some connectors here placed. And we need to do these as well. Yeah, here I have all the pins. So this one, for example, can be configured as con TX, con RX, UARTX, UARTRX. Okay, but maybe we should take these PTC3 and PTC2. PTC3 and PTC2. So we'll of course check if they need any anything else to them, but all the other con stuff. Wait, why is it? And then da, 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 da. XIO. For emulation of communication protocols and peripherals, UART, I2C, SPI, I2S, LIN, PWM, etc. So let's say PTD3 or 16, 15, 5. I can't remember 100%. But let's say 3, 2, 1. 3, 2, and PTD. Okay, PTA. Zero, 1, 2, 3. 0, 1, 2, 3. All of these here. And down on the PT 2, 3, 2. Five. 3, 2, and 5. Or 6, 7, 8. What about them? C, PTC 6, 7, 8. This one 6, 7, 8. I need to look over this Excel again. Let's see, but they can probably all be not the con though. The con has to be there, but the lin could probably be on any of these, if I'm not mistaken. Not mistaken. Thank you so much for joining the stream, guys. Nice to see people joining. Although I'm soon done for the day. Got a bit of a late start again. I stream more or less every day, Monday to Thursdays, after work and after everything, at around 9, I'd say. 9:30 maybe. Today it got a little bit later. Because I'm also learning German. So I'm doing my German course for about half an hour. And then I get into this. But yeah, I need to go back to the drawing board a little bit and plan a bit better what this controller should do and how I can make this controller for our projects. So we just want one box basically here right in front of us that either control or receives data from ECUs placed around the room, let's say. But it can't just be arbitrary. They have to have some functions, they have to have requirements on them, how they should act in different scenarios. For example, I can have this controller, for example, in a low power mode, and then I can have an ambient light sensor placed also in the room. It could actually also be on the controller. And as soon as I enter this room and I turn on the light, indicating that it should wake up, or it should switch some settings, for example in a day and night cycle. So during night it goes and does something, during the day it does something. So I need to plan this a bit better. But to be fair, I'm also quite tired today, and it's only Tuesday. Back to work tomorrow. But at least a little bit of progress was made. A little bit of progress is all you need. Okay, guys. I will head out. Thank you so much for watching, and until next time, ciao.